So now, from the last video, I foreshadowed combinations. So again, we introduced permutations, which is reordering lists. And then we get down to a committee where we wanted different groups of people, but order didn't matter. All right, so when we want different items, but order is either not important or cannot be established. All right, unordered sets, we use combinations. You still cannot repeat a item. That's the same for combinations and permutations. So if you repeat items, you have to go back and use one of our earlier methods of multiplication and addition for finding how many. Alright, so order is not important or it cannot be determined. An example of it cannot be determined is if you reach into a candy bag or a bag of marbles or something and you pull out 3 marbles all at one time or 3 pieces of candy all at one time. It's what we consider a handful of items, and so they were all selected at once. So there is no first pick, second pick, or third pick. There isn't one. You don't know which one was picked. So again, that's the you cannot determine the order. And so in that case, when you're picking out a handful of items out of a bag, that's a combinations case. Or the committee example where we don't have a rank, right? It's just a group of people. It doesn't matter how they were selected. They're all on the group, and the group has the same uh, rank, I guess. Again, there's no order of importance. There's no first place, second place, third place. There's no president, secretary, treasurer. They're just a group on a committee, and they all have the same committee responsibilities. All right, so there's no order of importance. There's no difference when I reorder them. All right, so that's the combinations. All right, when you have a rule, and I do have a typo here, and so the number of ways you select K, this should be R. The number of ways you select R items from N items, all right, when order is not matter, all right, but again, you cannot pick the same one twice, so no repeats. So combination, when you start with N items, so again, N items would be the total number of items. R is how many you're selecting from that total number of items. All right, so you'll notice the formula is very simple, but there is a slight difference. There's an extra value in front. That extra value in front takes away the reordering. So again, it's the N factorial, total group factorial, but in the bottom there are 2 numbers. There's the number of items that we're picking, factorial, and then the N minus R factorial. This is the formula, but like I said, just like with the permutations, almost all scientific calculators have a probability key, and permutations, combinations are the big counting techniques that we use in probability. So they're in there somewhere. Again, if you have an 84, 85 Inspire, there's a probability key. If you have a TI-30, there's a probability key. You just need to figure out where it is on your calculator and how you type it in. Alright, so again, combinations are used when you're selecting different items, right? No repeating items. But the order you select them in doesn't matter or cannot be determined. Alright, so combinations. So on the calculator, do try out on this on the calculator. So again, depends on your calculator. Some calculators, again, have little boxes down here that you fill in. This would be your 15 and this would be your 5. Or if you have an older calculator, sometimes you have to type 15 first and then 5. The 15, pick the combinations, the NCR on the calculator, and then type in the R, the 5. You can use the formula, but like I said, the formula is a little messier in this case, so I would strongly encourage you not to. I would strongly encourage you to find the But if you can't, you can always revert to the formula. The formula is provided for you. You don't have to memorize it. So it'd be n factorial, so this case it'd be 15 factorial, divided by, now make sure you're careful when you divide, put parentheses around it, r factorial, so 5 factorial, times 15 minus 5 factorial. So if you simplify that, that would be 15 factorial over 5 factorial times 10 factorial. And again, put parentheses around the denominator so you divide the 15 factorial times the 10. Otherwise, you won't get the right answer. However you decide to do it, or however your calculator does, you should check, again, make sure you practice this. It should come out 3003. Alright, so if you start with 15 items, you pick 5 of them, 5 different items, and you're not reordering them, There's 3,003. So you'll notice the number's a lot smaller than permutations, and it is because order doesn't matter. So the number for combinations will always be smaller than the number for permutations. All right, so in this case, we have 303 groups, different groups of 5 when we start with 15 that we're selecting from. All right, so do a couple more examples. If a classroom has 20 children, how many different ways can 5 children be chosen to participate in the new lunch program? Again, you're picking 5 different children, so no repeats. Right? Because you want to pick, if you repeated a child, you wouldn't have 5 kids anymore, right? So we were picking 5 different kids, so no repeats. So N is 20. We had 20 children to pick from. We're going to pick 5, so R is 5. It is a combination because order is not important. As long as you're selected, you get to do the new lunch program. Whether you were selected first, second, third, fourth, or fifth, it doesn't matter. If you're the first picked or the last picked, you still get to do the new lunch program. So order is not important. There's no rank to the selections. There's no difference in those 5 kids going to the new lunch program, and no matter how they were ordered, how they were picked. All right, so it's a combination. So combinations on your calculator, you go in and you type again. 20 is the N, combinations R is 5, so it depends on your calculator how you have to type it in. Hit enter and it should come out 15,504 different ways that we can take 5 children from 20 and put them in the lunch program. Now, there are 15, little over 15,500 different groups of 5 if we had 20 children to choose from. Right, the next example, suppose I want a committee. Whenever you see committee just means a group of people. Alright, so this is combinations. Alright, that one's a little easier, committee combinations. Alright, we want a committee of 8, so we're going to pick 8, that's my R, to be selected from a group of 20 again. So we had 20 people to start off with. We're selecting 8 of them to be on a committee. Committee doesn't matter what order you're in. You're on the committee as long as you're selected. Doesn't matter if you're first selected or last selected. You're on the committee. Alright, so it's a combinations case. And again, we have to pick 5 or 8 people, so you can't repeat people. If I repeated people, I would no longer have, right? If I picked Jim twice, well, he's only one person, so there'd only be 7 people, right? So I can't pick him again if I want 8 different people. So it's 20, combination choose 8. Again, type that out in the calculator. It comes out to 25970 different committees. Different. Basically, it would be that many different groups of 8 if I started off with 20 people and selected 8 of them. The biggest thing with permutations and combinations, you can only use them if nothing can be repeated, right? I can't pick the same person twice. I can't pick the same piece of candy twice. I can't pick the same letter twice, alright? So this is the case when there's no replacement, no repeating. Alright, you can only choose one letter. The letter can only be chosen once. Alright, so again, you can only use those in those cases. If it's repeats are allowed, you must use one of the earlier methods that we did, where again, typically it's a multiplication or addition between our different numbers. You can mix or and with combinations and permutations, right? I could pick, what I mean by or and is I could pick 3 people from 20 or 3 people from 15. So you would have 20 combination choose 3 plus 18 combination choose 3. Alright, so if I'm picking from different groups, suppose one of these groups are men, one of these groups are women. So I could pick 3 women out of 20, or I could pick 3 people for my group of men. So this would be, again, we can use and or. When we use or, we add. If we use and, so if I change this to instead of or, we go, I'm picking 3 people from 20 and well, then we multiply the two combinations. Alright, so again, we can use ands and ors and switch back and forth. So now we're just going to practice these. So I'm going to stop there, and then we'll pick up the examples in the next video.